Hi, everybody. In this lesson, we're going to make our first step into inferential statistics where we're going to make inferences. The rest of this unit is all about how do I make, so we're going to be making inferences. So you do this in English a lot, is where you have to infer what the author was saying or thinking when they wrote it. So we're going to be making inferences. In this case, we're going to look at data to make inferences about a population. To make using statistics, we're going to make an inference about a population. So we're going to talk a lot. There's not a lot of math in this lesson. There's just a lot of big ideas and concepts that are going to carry us forward. So a team of scientists want to determine the average length and weight of fish in the Hudson River. Describe the population of interest in a sample that can be used to help answer their question. So the population, what do I want to study? I want to know the average. The population is all the fish in the Hudson River. That's the population I'm looking at. I want to know the average length and weight of the fish in the Hudson River. So the way that I figure that out is I need to find every fish in the Hudson River and measure them and find their weight. Every single one. I need to do a census if I want to know about the population. I need that idea of every single person to find the true average length and weight. That can't happen. Why must a sample be used? You physically cannot find every fish in the Hudson River. I mean, I guess you could, but no, you're not going to do that. So we're going to use a sample. I don't know, maybe randomly select, I don't know, let's say 100 fish from the Hudson River. We're going to randomly select 100 fish from the Hudson River and find their length and weight. So the key thing is we're going to use a sample to make a prediction about the population. That's the key thing. We use samples to make inferences, to make predictions, to make an inference about a population. Instead of asking everybody or looking at everybody, how about we look at a sample of that population and see what their average is, and then we can guess about the overall population. So, for example, suppose you're the campaign manager for your friend who's running for senior class president. You would like to know what proportion of students who would vote for her in the election if the election was held today. The class is too big to ask everybody. There's 314 people. What do you do? So comment on whether or not these following sampling procedures produce a representative sample. When we take a sample, it has to represent the population. It has to be representative of the population. So what do I mean by that? I need the sample to kind of be random and fair and actually represent what the overall population looks like. So if I just poll everyone in my friend's math class, did everyone have an equal chance? Did all 314 kids have a chance of being selected? No, not all 314 kids could be chosen for this sample. Had a chance to be chosen. Not everyone's going to get chosen. Not all 314 kids had a chance to get chosen. Had a chance to be chosen for this sample. Also, if they're in your friend's math class, chances are they might have other classes with that friend. And maybe they're friendly outside of school, that group of people. So it doesn't represent the overall intentions or feelings of the senior class. So we can assign every student in the senior class a number from 1 to 314. So everyone's going to get a number. And then we're going to use a random number generator to select 30 kids to poll. So this is awesome. This is the best way to go. This is the best way to get a random representative sample. To get a random sample, this is the best way to go. I actually don't have my calculator sharing right now, so I forgot when I set up the recording to let my calculator show. But on your calculator, our calculator can spit out random numbers. So what our calculator would do is it would say 2, 37, 141, 200, 307, 5, 50, it would go on and give me 30 numbers, and then I'd go ask those kids. So this is the best way to get a random sample that's representative, because everyone has an equal chance of being selected. Everyone has an equal chance of being in the sample. So once you find those numbers, you go and survey that kid. So that's how this works, and that's how statisticians use it, is they use a random number generator. If you go on Google, you can type in a random number generator, and there's lots of different applets that you can use to randomly select numbers. Or we could ask every student who goes to the football game on Friday night who they would vote for. I've got lots of issues with this. We're asking every student. Not all of them are seniors. Not all are seniors. Why are you asking freshmen who they're voting for the senior class president when they don't have a say? So your sample has to actually be from your population. Your sample should only be from that population. You can't sample other people include other people from outside that population in your sample. That's not going to be representative. Also, not everyone goes to the football game. Not all seniors go to the football game. So they don't have a chance of being selected. Also, if you're at the football game, maybe there's a lot of sports fans there, and people who don't like football aren't there, and maybe your friend doesn't like sports, and it's not going to be a representative sample just picking people who are at the football game. That's not a fair, neutral place. That's not a neutral place to pick people from. So the best way to do it is to use some kind of random number generator to randomly pick kids. So when you get a random sample, everyone in that population should have a chance of being selected to be part of that sample. And you want to do it randomly. You don't want to pick. It might be easier to ask your friends, the kids in your friend's math class, but that's not going to give you a true representative sample of the population. So here's the whole idea going forward, and here's kind of a huge idea of what inferential statistics is all about. So statistics is all about when conducting a statistical study, a question is asked about a population. So I'm starting up here. I have a population that I want to know about. Well, what do I want to know about that population? It could be one of two things. It could be the proportion. It could be a proportion of something, like how many kids are going to vote, what proportion of people will vote for my friends. Or it could be a mean. It could be an average. What is the average length of the fish in the Hudson River? And these numbers are called parameters, and they're unknown. So these are unknown values. So the proportion, we use the letter P, and for means, we use the Greek letter mu. It's like a U with a tail on the other side. These are called parameters, and these are unknown values. These are parameters, and they are unknown. I do not know what the average length of every single fish, what the average length of all the fish are in the Hudson River. I will never know what that parameter is. I will never know what that mu, that average, that population mean is. Or when they do polling, they're trying to guess what the true proportion is. They're trying to guess what the true population proportion is. So these are values from the population, and they're what we want to know. They're unknown. So what we do is we take a representative sample from our population. So we take a sample from our population. And the key thing is this sample needs to have some kind of randomness to be representative. I need randomness so it is representative. I need a good sample from my population to make my statistics meaningful. So from my overall population of everybody, I take a sample, probably like 10%, I don't know, 5%, depends on the size. But you take a sample of the population. And from that sample, you look at these things called statistics. So it's called a sample proportion or a sample mean. These are called statistics. It'd be nice if I spelt it right. These values are called statistics. Close enough. So the way that we represent a sample proportion is p hat, p party hat. It's got a little hat over it. And the way that we represent a sample mean is an x with a line over it, x bar. So we use these values. These are known values. We use statistics to estimate parameters. We use these values to make predictions or inferences about our population. We use sample statistics to estimate population parameters. And it's this very complicated process. It's not the most straightforward thing that we do. But from my population, I take a sample, then I compute a statistic from that sample to estimate estimate some kind of parameter. Clearly, a sample proportion estimates a proportion, a population proportion. A sample mean estimates the population mean. The problem is when you take a sample, variability happens. There's variability in these sample statistics, and that's what we're going to spend the rest of this unit looking into, is how do we deal with the variability in our sample statistics? Because every time you take a sample, these numbers are going to be different. So this whole idea of inference is, how do we deal with variability? There's variability in our samples. The sample I take from a population is going to be different than the sample you take. So there is variability. Try that again. Variability when we sample. And we'll look at that next week. How do we deal with that? But I need you guys to understand what we're doing here. I have a population, and there's these things I want to know about that population. But I'm never going to know those things because they're unknown. So I take a sample of that population and compute something I can actually work with. I compute a proportion or a mean, a p hat or an x bar. And then from those values, we're going to use some kind of statistical procedure to estimate these unknown population parameters about the population. So we're going to use sample statistics to make inferences or estimates about the population. That's what's coming our way. We've got a couple things left in this lesson. That's a lot easier than everything I just said, and we'll call it a week. So the manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup with a soft drink instead. What a crime that is. So the manager selects a random sample of 80 customers, I don't know, there's a little typo there, who asked for a water cup when placing an order, and found that 23 of them filled it with a soft drink. Ooh. Determine the sample mean or two typos and one problem, or sample proportion for this situation. So, is this an average? Or am I working with an average here, or am I working with a proportion? So in this case, I think I'm working with a proportion. I'm working with a p hat. My sample proportion is what? 23 of them filled it with soda out of 80. So my sample proportion is 23 out of 80, 0.875. So right now, that's my sample statistic. Right now, we had a population, everyone at the fast food restaurant. I took a sample of 80 people, because I can actually work with 80 people, and I found a sample proportion from 23 out of 80. And what we're going to do later this week is realize, how do I use that p hat to make a guess about the true population proportion? That's what we want to find out. But right now, we just found a p hat. We computed our sample proportion. A random sample of 10 words was pulled from the Gettysburg Address shown below. So I randomly picked 10 words. I used a random number generator and pulled 10 words from the Gettysburg Address. So I got the, resolve, score, consecrate, final, the, nobly, the, endure. Determine the sample mean or sample proportions for the situation to estimate the true average. So I'm working with an average here. That's not a proportion. That's a sample mean I'm finding here. I'm finding an x bar. And what am I looking at? I'm looking at the word length. So I'm looking at with how long the words are in the Gettysburg Address. So I want to know, on average, how long are the words in the Gettysburg Address? Instead of looking at every single word, right, that's my population, every single word, I took a sample of 10 words, and I'm going to compute a sample mean. Then we're going to use that sample mean to estimate the true population mean. So how do I find my X bar here? Well, how long are these words? 3, 1, 2, 3, 4, 5, 6, 7, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a big word there. It's a hard one to say. Final is 5, the is 3, 5, 1, 3, 1, 2, 3, 4, 5, 6. So how do I find a sample mean? What does a sample mean? Well, how do I find the average of something? 3 plus 7 plus 5 plus 10 plus 5 plus 3 plus 5 plus 1 plus 3 plus 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things. I divide it by 10, right? How do I find an average? I find the sum, and I divide it by how many things I added up there, my sample size. So I got 48 out of 10, which is 4.8. So my sample, the average word length of my sample mean is 4.8. That's my sample statistic that I'm going to use to estimate that true unknown population parameter mu. Mr. Cromer was interested in the time it takes students to run a mile. He randomly selects, that's good, he's got a randomly selecting 3 sophomore level English classes, and each student reports his or her mile time. The mean, this is a sample mean, our X bar is 498. Identify the sample and population in this given scenario. So the population, well, I think it's easier to find the sample first, because the sample is what we're going to use. The sample are the 3 sophomore English classes. The kids in those classes, I should say. So the population, I can't just magically now talk about juniors because I didn't sample any juniors. So my population is all the sophomores. All the sophomores in the world? No, I guess it would be sophomores at CCHS. That's who I can make the inference about. Because my sample is from 3 sophomore English classes, I can only go back and use that as my population is all the sophomores at CCHS. What conclusion can he make about the population? Our best guess right now, for the population mean, for the true population mean, which is the Greek letter mu, is 498. That's our best guess right now. Our sample mean was 498. That's our best guess right now for the population mean. My sample had an average of 498, so my guess is the population average is 498. It's not going to be perfect, but that's my best guess right now. And finally, Mr. Flannery, Flanman's AP Stats class is investigating what proportion of 11th graders at our high school are taking at least one AP class. The students went to guidance and got a list of 265 juniors at CCHS and numbered them 1 to 265. A random number generator, I got the typos everywhere here, was used to select 40 students. They found that 14 of the 40 students were enrolled in an AP class. State the sample proportion. So what's my p hat value here? Well, how many of them are taking an AP? 14 out of 40. So my sample proportion, my p hat, comes out to be 0.35. That is my sample statistic that I have right now. Identify the sample and the population. So the sample is the 40 juniors that were chosen. The population, well, where did that sample come from? It came from the 265 juniors at CCHS. I can't go and make a comment about Washingtonville kids taking AP classes because I didn't sample any Washingtonville kids. I only sampled kids from CCHS. What conclusion can Mr. Flannery's AP Stats class make about the population? So our best guess right now for the true population parameter, for the population proportion, that true unknown value, our best guess for the population parameter, the population proportion, I should say, because it's a proportion, the population proportion is that 35% of juniors take an AP class. Is it exactly 35%? It could be, it might not be, but it's probably around 35%. And that's what we're going to look at going forward is, all right, my sample said 35%. What do we think the true proportion could be? What do we think that unknown value could be? What kind of inference technique? What can I do with my sample data to make that estimate, to make that inference about my population? And that's what statistics is all about, is how do I make this? That's what we spend the rest of this unit on and the rest of the course on, is how do I make these inferences? So hopefully you notice there's not a lot of math this week. There's a lot of big major concepts and ideas that we're going to use going forward. See you guys in the next video.